Here we're looking at a vector addition problem. There are many vectors you will run into in physics, so the strategy we discuss here can be used in the future for adding displacement vectors or force vectors, momentum vectors, whatever the case may be. Here we are trying to add velocity vectors together, one for this airplane, one for the wind that it will fly into. So the airplane itself is flying north. It will encounter this wind directed southeast, and the goal is to find the overall velocity of the airplane while it flies through the region with the wind. Let's draw a visual for this vector addition. The airplane itself is flying north. If there was no wind, the plane would keep flying in this direction in this straight line. But when it runs into the wind will push it in the direction that it's blowing, south and east. So we add that tip to tail. At the tip of the airplane vector starts the tail of the wind vector. And so the airplane itself will travel in this direction along this purple line. It will still be moving north, but now it will be moving a little bit to the east or to the right because the wind has pushed it that way. So our goal is to find the magnitude and direction of this vector v pointing in the northeast direction. If you notice, this is not a right triangle. So basic SOHCAHTOA and Pythagorean theorem aren't enough here. We're going to need a little more complicated analysis. For more complicated vector addition problems, I think using a table like this would be a good strategy. Vertically, you're going to want two rows, one for the x-axis and one for the y-axis. Horizontally, you're going to want one column for each individual vector that you are adding. So here we have the airplanes column and the winds column, and then additionally, one more column for the net vector, or the net result of the airplane and wind together. Let's do the airplane first. This is an easier analysis. This is flying straight north, so it has none of its velocity directed along the x-axis plane. I'll put a 0 there. And all 250 meters per second are directed in the y-axis plane. I'm choosing positive 250 because we're flying north. That would make sense to be positive. If this plane were flying south, I might make that negative. For the wind, this is more complicated. It is an angled vector, south and east. So 80 is the total velocity, and 30 degrees is the given angle. Drawing in the components of this vector, Wx will represent how much of the wind points along the x-axis, and Wy, how much of the wind points along the y-axis. Here using SOHCAHTOA, I'm going to do 80 cosine 30 to find the Wx component, and I get 69 meters per second. That points to the east. I'll keep that positive, and that will go in my table for the wind x value. Wy, I can find that with 80 sine of 30. The math will give me an answer of positive 40 meters per second, but I observe that this vector points south. That's in the negative y-axis, so I will make that negative 40, and that's what I'm putting in the table. For the net vectors, we just read left to right. X-axis, I have positive 69 meters per second. Y-axis, 250 minus 40, I get positive 210 meters per second. So from here, we're just going to try to find the overall value of vector v. Starting with the components we've solved for, this vector has an amount of 69 to the right and 210 north. This is the vector I'm looking for, connecting the beginning to the end of my vector addition, and I should find the angle as well, so I can state this vector's exact direction. Doing the trig would produce the final answer. 221 meters per second is the magnitude, directed at an angle of 72 degrees north of east. For more complicated vector addition problems, those that don't deal with right triangles, consider making a table like this. Your goal is to find the net x and net y values so you can get back to a right triangle and use your basic trigonometry skills. If you found this video helpful, then I have other resources that you may be interested in as well. For more information, check out my website, shoot me an email, or follow me on X and Facebook. All of the links can be found in the video description.